On a lovely raining morning, just collecting a bit of rainwater to test the pH. It should be slightly acidic. Okay, so we have 4 beakers. In 3 of them we have water straight from the tap. Into the one on the right of the video, I'm just putting a bit of hydrochloric acid. Let's go one more squirt. So that solution is now acidic. Into the next one, I'm putting some sodium hydroxide. This is a strong base. So we have an acidic solution, and next to that we have a basic solution. Next to that we have water straight from the tap. Now, they all look like water. They all look the same, but what we can put in is universal indicator solution. In an acid, this is red, depending on the acidity, yellow to orange to red. So if we drop it into the hydrochloric acid, we see a definite red color there. Okay, so universal indicator solution is red in acid conditions. It's blue or purple in basic conditions. A base you can kind of think of as being the opposite to an acid. So we can see it's a good indicator to use in terms of it gives us a nice color to observe. So we can get an indication of the actual level of pH. Some acid-base indicators will just tell you if, oh yeah, that's an acid or that's a base. Universal indicator solution, because we get a range of colors like yellow to orange to red for acid, depending on how yellow or how orange or how red, it gives us an idea of the actual pH. So the first one would be a pH of about 1. The purple ones, very purple, that would be a pH of about 13, 14. Of course, 7 in the middle of the acid and base pH scale is neutral. So tap water should be green. And sure enough, you'll find tap water is indeed green. Green says neutral. Okay, so for universal indicator solution, if you put it in the solution, you get a nice green color. That's neutral. It's not an acid, but it's not a base either. Okay, acids on one side of neutral, less than 7, and bases the other side of neutral, pH more than 7. Now, what I did this morning was collect some rainwater. So the first 3, because we're just water from the tap, this is actually rainwater. If we throw some universal indicator solution into the rainwater, let's see what happens. Now, there's still a greenish color there, but it's sort of a yellowy green, isn't it? In fact, you could even argue that that's closer to being yellow than it is to being green, right? Once I stir it around a bit. That is a definite yellow color there. Now, yellow, with the universal indicator, says acid, okay? The acid side of the pH scale with universal indicator solution, yellow to orange to red. So rainwater is actually acidic. Okay, we don't usually think of it as being, acid rain. It's just the normal stuff. Now the reason that rainwater is acidic. So what we have in the atmosphere is CO2. We've also got a lot of water vapor up in the atmosphere. The thing about CO2 is it will quite happily dissolve in water. And when we dissolve CO2 in water up in the atmosphere, what we make is H2CO3, hydrogen carbonate. Now the common name for H2CO3 is carbonic acid. So this is what rainwater actually is. It's actually carbonic acid. It's a weak acid, so we saw the pH was a little bit less than 7. For rainwater, the natural pH is about 5.6. Anything less than 7 says it's acidic. Okay? It's only a weak acid, so we're not down around the pH 1 or 2. Okay? It's not that acidic, but it is actually slightly acidic.